Okay, so am I audible?
Yes, sir.
Okay, so let's start today's expert session. So first I will introduce the expert. Uh, just my voice is echoing. Just a second. Ma'am, Khushbu ma'am, can you please mute
Okay.
because your voice is echoing. Okay, so let's start today's session. First, I will be introducing the expert. So today's expert is Miss Khushbu Derji. So, good morning to respected faculties and my dear students. Today, we welcome Ms. Khushbu Derji as our chief guest, expert talk speaker on the topic IP addresses and subnetting of networks. Ms. Khushbu Derji is a freelancer network advisor and member of ISRO's SEC department. With a lot of in-depth knowledge and industry experience can be seen in her past endeavors with over 7 years of industry experience. Khushbu Derji has worked at ISRO SEC Department, KT Automation, and Intelligence Power Communication. Ma'am had completed her post-graduation MTech in communication and have also published research papers on hybrid approach digital image reconstruction using comprehensive sensing technology and a review paper on implementation of hybrid approach based comprehensive sensing algorithm for image reconstruction, which contributed greatly to the field of technology and science. Ma'am is a certified network expert with a major Gold Network Plus certificate holder. I request Ms. Khushbu Deji to start today's session and shed light on our students with her great knowledge and expertise. Thank you.
Thank you, sir. And thank you for having me. It's an honor. Okay, so, sir, shall I start?
Yes, ma'am. Yes, ma'am. You can.
Okay, good morning, all class. We are here gathered to understand IP addresses, network, and its subnetting. Okay, so before we start, we need to understand why this is important for you as a computer science field. In future, if you want to just go for a network penetration or N plus or CCN anything, so this is the basic thing that you understand, and just to go with more knowledge when you enter in your field in future. Okay, so first of all, we are going to understand IP addresses, uh, why IP addresses is required, what is IP address, and why we need subnetting of it. Okay, so let's get started. First of all, what is IP address? Of course, we know that physical address, or you can say the MAC address, media access control, that you used in a data link layer. This is the physical address, and then this physical address is converted into the logical address in network layer. Okay, so first of all, this is internet protocol is used in a network layer as a logic address. I'm giving one example that the physical address considered as your home is your residence, and the logical address is the logic address that some packages or later or something routes your house and get with you. So both are important, but first of all, we are just focus on the logic address. Okay, so this is IP address important to identify, and you get the identification, authentication, and to secure communication with you, your package, and some another network or workstation or any server. Okay, so this is the important of the IP address. If it's not IP address here, then your package would be go any one other workstation or any other uh, uh, you can say like some another network or some other workstation on the host. Okay, so IP address is important. Now the another thing is a logic address that I am giving the example of 117.149.39.2. Okay, so this number is we can see here as per our understanding, but the machine router is not understanding like this. This has to convert in the binary language. Okay, so binary language is has to divisible, or you can convert the binary by using 2. Of course you know that because in your first year of college you might be got subject of digital communication, right? So this logical address, it's in binary uh, of IPv4 version 4. And IPv6 is another type of IP address, and it's in a hexa language of the digital communication. So here is 117.149. It's converted into the binary language first of all, and then just go with the process of a router to another router with all the way. Okay, so here I am giving a 2 type is in on all the world is 2 to the power 32. It's 32 is a bit. Okay, of course you know that the 1 byte is equal to 8 bits. Okay, and 4 times 8 bits it's become a 4 byte, or you can say the 32 bits. It's not like that 32 bits only there for the IPv4, and this separated, or just globally giving the address is only 32. It's not like that. We will go further. Okay, and another one is IPv6 is 128 bits. It means 8 bits. It's 16 times, then you get 16 bytes, and 16 bytes it's mean 128 bits. So this is the difference between the IPv4 and IPv6. This is the basic thing that might be you know already. Okay, now we see here it's a type which is public address, private address, static IP, and dynamic IP. Okay, so first of all I would say it's we are going to focus on IPv4 because you will get even a over 4 million network from this IPv4, but it is not good enough from this population. That's why IANA is generated or given IPv6 too. Okay, so let's get started from the public address and the private address. As you can see here, public address, I'm giving one example of public address is Google. You know already the public address of Google is 8.8.8.8, right? You can use it, you can find it. This is the public address of Google, but you cannot do anything regarding this, right? Because it's you cannot penetrate in it easily. It's a higher security and higher firewall is standing there. Public address is used for you can connect your private address to publicly. It means like globally you can connect with all over the world. That's why public address is important. Okay, now another thing of the public address is you can uh, not to change, like it is a unique address. Now I would say that if you want to just go to Google and you use Google IP address, IP global address is 8.8.8.8. Okay, but you cannot make your own Google by this IP. Of course not. It's a unique and it's a permanent. You can change it and you cannot do anything for it. Okay, but the important of the public address is you can just search or you can go through the anywhere in the globally that you can connect with. It's not any boundary of it. Okay, now this public address is connected with the private address. Okay, with some boundaries, with some security, and with some authentication. Okay, now another thing of the public address, I would say, it's router. It's you might be used at your home or somewhere else. The company of Airtel, Geo, or AT&T, anything, it has a public address. Okay, this public address is for a company. It's a particular huge company, a huge organization. Okay, so this company got this IP address, public IP address, by the ISP, internet service provider, and this internet service provider get the authentication by the IANA, which is internet assigned network authority. Okay, so this is all thing is legal and you cannot do anything. Of course you can do if you want to find the bug or you want to penetrate or something hack or on, but you cannot do easily in it because this is public but somewhere it's secure. Now let's see in the IP address of a private one. Private one that I'm giving example, it is like you are connecting router with some another appliances or devices. Okay, so you are just giving your own IP address with respect to their range. Okay, you are not going to ISP or IANA like I want IP to connect my printer or connect my another host or connected my another workstation. No, it's like you can connect it with LAN, and the admin one is connected from to your device, and it is easy to connect it in private address. Okay, more understanding with this public and private, I would say that the public IP is connected with a mesh topology. Okay, the public IP is connected with the router that use the star topology. Okay, and this ring or ring topology, bus topology can use by the private address. Okay, so this public address is all the mesh topology used, and the private address you can use the bus, ring topology, or tree topology. Okay, so this is the basic thing of the IP address, public and private. Okay, now let's see another one is a static IP and a dynamic IP. All right. uh, First of all, static IP, as you see on the diagram, that server is connected directly to the static one, and in the dynamic IP is connected with the DHCP server, which is provided the dynamic host config protocol. Okay, so this is a direct one which is static, and the DHCP service required for the dynamic IP. This is the simple one, but let's get to in thorough that you can see here that a router is connected static and the dynamic one. Okay, so this static and dynamic IPs are connected with the router. If I see the static which is manually connected with the all workstation, or you can say host. Okay, so manually connected, it means that you are type or you are configure router by your hand, by your physical connection, and you know what is the range, you know what is given IP to another workstation, or is like a main workstation is controlling all things, but it is manually connected. Okay, and whatever is manually connected with IP to the another workstation, with IP to another server, is connected manually, and this IP is only in this router table. router table, it means the static container addressable memory. It's called the CAM table. Okay, so this is just to store as it is in the CAM table or CAM memory. You cannot change it. Okay, you cannot change the IP. This IP is given with respect to their MAC address. So this MAC address have this IP only. You cannot change it. Okay, so this is permanent. Okay, so this is the static one, right? And I'm giving like a static one has a more security as well as dynamic also. Why? Because the table cannot change, the IP cannot change with respect to the MAC. Then you cannot penetrate by another IP address until you don't know that what is the list of that workstation, main workstation or the router, right? So if you want to know that what are the IP in this MAC of the static router, you just go and apply the ARP protocol, right? This address resolution protocol that you can use and just go and penetrate inside. But you can just see whatever happened, but your IP address is not matched with another one that you cannot penetrate to. So this is also secure one. Okay, static is also secure one, right? And the static one is used for a particular organization, it with the small office area with the small workstation. Okay, now let's see the dynamic one. The dynamic one is generated IP addresses by own. It means like automatically you just generate it. It means you just go and use the command the IP config. Okay, now this is you get the IP of your laptop, and when you just point on the DHCP server and your class of the IP, then you get IP automatically that you want to connect with your another devices or appliances. So you can generate from the DHCP, you can generate the IP easily. Okay, another thing of the dynamic is you can change it repeatedly or as per the setting or configure of the router. It means the all IP address, all MAC address, okay, all domain name is just on the list on that CAM table. Okay, but as per the router configure, it's like updates are there, or you can say the expire of this cache memory, or you can say that just changing it or like that. So it's changing their IP with respect to time. Okay, some router has configured to changing IP address. Okay, it's not a permanent IP, but MAC address is same. Okay, so if the router change the IP address like 30 second or 5 minutes per day or per week, so IP address can be changed. But with respect to the MAC address, now the router know the new IP address and their MAC address. Okay, so this is also secure one. And if you penetrate and you want to hack someone or some devices, you know this is IP address of these devices. But we don't know that router has configured to change this IP address in 30 seconds, right? Then you cannot just go penetrate of IP address, the same IP address as well. So this is also secure. Okay, now another one to using our protocol here, some like you have the all network system or the all workstation are connected. If you go in it by the R protocol, that what you do, it's like a broadcasting and asking for the acknowledgement back that some is working there or not. This is uh, this is open area to go inside or not. Okay, so somehow that by the workstation you will get the acknowledgement back, but somehow it's not, might be the device is not working, might be the host is not there. Okay, so it means that the ARP acknowledgement back is not giving any kind of answer. At that time, you can use that IP address for the another device. Or at that time, router can put that IP address to another workstation. Okay, it is also possible, and it is also possible if the cache expire time is there, that you can, it's just router can change the IP address, but the MAC address would be same. Okay, so first of all, whenever you see the OSI layer, whenever you want to transmit the data, first you can see the MAC, then IP address, and whenever you see the receive the data, you see the IP and then MAC. Okay, so these are going to match, and then you get the packet. There is no any mismatch in the dynamic one, but it is secure also as the static one. This dynamic one can use for uh, the huge network. Okay, all right, now let's see the another one of the IP address classes. Okay, so IP address class is A, B, C, D, and E. We are not talking about the D and E because it's used for the multicast address, and E is reserved. Reserved of what? Reserved of to research something on a network, research or something, discover something new, testing is going on globally. Okay, so it comes in a class E. Class D is for the multicasting address. So at present, we are going to understand class A, B, and C. First of all, you can see in this diagram, as we understood before, there are 4 bytes. Okay, so 4 bytes, it means how many bits? It's 32 bits. Okay, so first is class A. It's called net ID. Net ID means the network. Okay, and host means the host or the workstation ID, that you provided IPs with respect to the network. Okay, so byte 1, it means the 8 bit is applicable for the network, class A IP, and the rest of all is 24 bits is for the host, that you connected 24 hosts. It's not just 24 hosts. As I say, it's convert in the binary, so you just do 2 to the power 24, that kind of host considered in class A. Okay, so first 8 bit for the network and the rest of 24 bits for the host. Okay, now class B is what? That 2 bytes are connected for the network. 2 bytes, it means the 16 bits are used for the network, and the rest of 16 bits are used for the host. Okay, now class C is 3 bytes are provided to the network. Okay, so it means the 24 bits is provided to the network, and the rest of all for the host ID. Okay, host ID, it means that whatever given the network, whatever given the IP address is, it has the workstation that you can connect it by the 24 bytes, by the 16 bytes, and by the 8 bytes. Okay, as well as here is you can see the network one, class A used for class A network used for the 8 bytes, then class B used for the 16 bytes, then class C used for the 24 bytes for the network, and the rest of all for the host. Host that you can connect it, the all organization or all workstation together with this network only. Okay, so this is the class of it. Let's go thoroughly in it more. Now, if you don't know the how to convert in binary, that this is the easiest example that I put here, that you can convert the binary into the decimal with a 2 to the power 0 to 7. Of course, it's 7 only. Okay, not a 16. This 2 to the power 16 would be used in the IPv6. Okay, because it's become a hexa. You know that after 9 it start with A, B, C, D, E till F. Okay, you might be seeing your phone or something that anxiety IPv6 IP is also there, but we are focusing here for the IP binary for the version 4. Okay, so it's 8 bit, each have 8 bits. So here consider 2 to the power 0 to 7 is total 8 bits. Okay, now if you count the power, it's get till the 128 only. Okay, now let's see up here. Downside, it's given the IP which is 172. Okay, so how we get the 172 here? It's here the 1010110. How we get it? It's a 172. So 1 we get from the 2 to the power 7. We get 128. Then plus 32, which is 2 to the power 5. Okay, then 1 and 1, 1 and 1, 2 to the power 3 and 2 to the power 4. So if you just add up 128 plus 32 plus 8 plus 4, then you will get the 172. Okay, 172 is the network one. It's an octet that is called the network ID. Okay, as we see in the last slide. All right, so as well as here this 16, then is 16 is only 1, and this one we get up here only, which is 2 to the power 4, which is 16. So this is the one, then we get the 16 one. Okay, and rest of all is 0. It means the decimal number is 16 of the IP address. All right, then here is 254. Okay, so total you just add up all this number, you get 256, right? Maybe you see the masking of this IP address like 255.255.255.240, right? 240 or 124 like this. Okay, so total adding up of this binary is 256, right? But we're starting from the 0. That's why we count 0 to 25 only, 0 to 225 only. Okay, so here is given 254, right? So 254 is given with what? The all is 1, not this one. Okay, if you just 255 minus 1 subtract with 1, then you get the 254. So this is you convert in the binary, and this binary language is understood by the machine which is working inside of your laptop or any network. Okay, so this become a 32 bits, and with respect to the 32 bits we are just converting the IP address in the binary. Okay, now let's see that as we understood already that 8 bits and 28 bits for the network ID, and the host bit is 24 ID for the class A. What does it mean? Okay, so here is networks that we are getting from the class A is 2 to the power 7. Why? Network is mean the network ID. Okay, so here is 7, so which is applying 0 to 7. Okay, if you do the counting of 2 to the power 7, okay, it's 128, right? And which is apply on 0 to 7. So networks are 128 networks which is provided by the class A. And what are the rest of all? If you just subtract 32 minus 7, then you will get 24. Okay, so rest of all is what? Host. Okay, the host that you can just generate the IP, and you can connect the host or workstation, which is 2 to the power 24. How we get 2 to the power 24? The network ID is 0 to 7, which is the 8 byte. And the rest of all, that is 32 minus 7, then you got the 24. So if you convert in the binary, which is 2 to the power 24, then you got this number, okay? And this number and this kind of network of hosts, network is 128 and its host is this much, okay? So this is the class A power that you connected like this, all right? Now, the range of the class A, this 0 to 127. Why is 127? Because here is a network is 128. It means 0 to 127. Okay, this is the range of IP. The class A, which is 0 to 127. Class B is 128 to 191. Class C is 192 to 223. You can also, you know that you can check your phone IP, your another IP address that in a college network, or your own IP address is connected with this range only, is 127, 191, or 223. Most of this connected with 192. All right, it's 192. It means what? That you are connected with the class C only. If it's 128, between 128 to 191, that you are connected with the class B. Okay, and if it's a class A, then you connected with 0 to 127 range, that you can identify that what class is using, what class of IP you are using. Okay, so this is the range of the IP address and its classes. Next, see the class B, that we know that already that 2 bytes are used for the net ID. It's 2 bytes, which is 16 bits. Okay, so 16 bits is used for the network one, and the rest of 16 is used for the host one. Okay, so you can generate 2 to the power 14 network, okay, and 2 to the power 16 network. Now you consider why it's not 16 here. We have to first bit and the last bit for the checksum or just a gateway. Okay, you know the gateway and the broadcasting, they use the 1.0 for the gateway. It's a gateway. If you want to connect the network from the gateway to another device or globally, then the byte is become a 1. Okay, first byte it become a 1, and the last byte is for the check or the like it is getting this acknowledgement, is getting the package or not, then the last bit become a 1 as the acknowledgement get. That's why it's a 14. Okay, in the class C, that we can see here that the 24 is a net ID. Okay, so rest of all is what? The network. Okay, so here is 24, and the 3 bytes are required for the gateway, for broadcasting, and for to check the acknowledgement. Okay, so class C is 3 bits is required for leading bits. It's called the leading bits. So it's a check first. These leading bits are okay, and then start the packaging by the root. Okay, so this is the class ABC. It's class ABC and their network addresses and the host addresses. That you can see here, you get the network address and the host we generate this much. In class B, the address network is this and address of host is this much. Okay, so this is not just 2 to the power 32, but in between there are so many process done that you can even generate over the 4 million networks in it. Okay, but this is not good enough. That's why we are jumping in the subnetting also. Now, let's see this subnetting. Uh, just a second. Before that, I want to explain this subnet mask. Okay, before we start this subnetting, let's uh, get some more uh, knowledge for the subnet mask. What is subnet mask? Okay, So you know the total is 2 to the power 0 to 2 to the power 7. Okay, this all together and we get adding up of 225, 0 to 25, which is total is 256, right? In class A we are using only network 255, and the rest of all is host. This is the better to understand the classes of the IP. Okay, so network is 255 and the rest of all is host. So you can count the host is as per the subnet mask. What is subnet mask? Which is 255.0.0.0, which is subnet masking. Okay, if you saw the 255 and the ranges of 0 0 0, some random ranges are there, then you can understand that this is the class A IP address, and the ranges of host is nearer around approx to the 126 one, not more than that. Okay, now in class B you can generate the network, which is the a byte that you add up in the binary. You will get the network of 255.255. Okay, so this 255.255 is two times that you can know. You can just identify this is the class B IP. Okay, so this IP is 250 by 250 by, this is the network one, and the host they're using with respect to this class B is generated in last two octet. Okay, so you can identify the IP class. In this class C there's three uh, 8 bytes. Sorry, it's not 8 bytes, it's 24 bytes. It's 24 bytes is connected, convert in the binary, and we get the decimal, which is 255.255.255.0. So you can find the range of the host if you want to go to penetrate in it. So you can identify this is the class C IP and you want to go inside. You can see the host is like this range to this range. So you can apply the ARP from this range to this range. You can identify the host and which hosts are working on these packages, right? So this is the important whenever you go inside the network, that which IP is used, okay, which subnet mask is used, and from the subnet mask you can get the host range. Right, now let's see more understanding this subnet mask. Here is I am giving the example of 255.255.255. Here is three times of 255. It means what? This is the class C IP address. Okay, now class C IP address and host is 192. Is 192 if you get in the binary, like the right, then you can get 1 1. 1 1 means what? It's 128 plus 64. Okay, if you get the 1 1, it's 128 plus 64. You adding up, you get 192, right? So if you put the 1 1 on this, then you get the subnet also. You get the subnet from this way too, and the rest of all is host. Subnet is what? It's a network. It's a network one that which is given by the subnet mask, which is class A, B, C. Okay, and whatever the range of the subnet, and the rest of all is the host. That you just understand, this is the class C, and the range is 192. Okay, the network is comes in a 2 bits only, which is 192, but rest of all is host. So you can go and penetrate the rest of all is host from the network of the class C, and the range is 192. Okay, as well as here the second example, which is 224. Okay, so 224 you get is 224 network ID from the 128, 64, and 32. So these three are the network ID only. Okay, and the rest of it is what the host. rest of it is host. So you can find the IP address between the 224 range and you go inside the network. Okay, as per your field that I'm trying to explain, the how can you just go inside and penetrate with the IPs. Okay, now you may arise the question that why only this one, two, three, six zeros are here. Why six zeros are here? As we know now that class C is what only 8 bits are host. Okay, that's why I'm putting this 80 here only, right? But if it's class C, then I have to add up these two hosts, and this kind of host is adding up more. It means if for example here is only 255.255, right? And here is I'm writing 192, right? So you have to just add it up the last octet bytes, octet byte, and this one also. Then you get the host only, and the rest of is network one. Okay, so this is the masking that you able to and you often see in all the devices. Now you know that what is the classes, and if you know the host number, then you can understand these ranges of the host that's connecting devices. Somewhere is working, somewhere is not working devices, but these IPs are provided by the classes. Okay, so you know the all the subnet masks of the class A, B, and C. Now let's see about the what is subnetting. Okay, we know that class A, B, C is required for the generate and provide network and the host. But the subnetting is what that a subnetting which whatever is network is provided by the class A, B, C, and then you have to substitute more network from in it. Okay, now I'm giving the example that in class A there are more what there are more hosts and the less network, but we are using class C uh, host. Okay, host, it means the net host, and we are using the network from the class A and class B. This is also could be happen. It means if we are using network from the class A, which is 128, but I need more networks for the huge organization or company are globally connected, then we can use network with respect to the host of the class B2 or class C2 if we are using class C. Okay, and its host is 256. Okay, and this host is not good enough for me, so I'm jumping in a class B and get their host too, right? So this is like giving and taking and borrowing the bits from the other network, from the other class. Then it's called the subnet. Okay, so this is the subnetting to the main IP addresses are there, but you are just breaking the IP and the taking bits or borrowing bits by the other network, or you just generating like a substitute of this IP address. So it is called the subnetting. Why it is required? Because devices are workstation hosts are increasing day by day, so is giving and taking bits or borrowing bits is usable to sending the network. Okay, sending the network means to sending the package or that it is usable for the subnetting. Okay, now another thing of the subnetting which is you see here, that is a class subnetting. Whatever we are using class A, B, and C, so that particular IP address, and from the IP address you can borrow the bit in between this ranges of 128 to this 2 to the power 24. You can borrowing bits for that and make your own network, make your own host. Okay, but if it's not in a class A, B, C, it's not a 24, it's slash 24, it's slash 16, it's not a slash 8. It means what? That you are borrowing bits from the other class. Okay, the IP address is starting with the 192, which is class C, but it's not a slash 24. It's slash like 17 or 7 or 25. It means what? Class C is there for the network one, but the host is there for the another class. Okay, maybe you see often that in your cell phone or in any network it's a slash 24 slash 16. It means what? That you are using this class host, you are the part of this host of this network and this class. Okay, but this is the 24, 60 and 8 is there, so you are using that particular class ABC, but it is not in this range. It might be 27 or 25 or 17 or 7. So you are using the class of ABC, but you are the part of their host with some another class. Okay, so it is like that to understand the high how it's just giving and taking bits, borrowing bits and just giving bits and just reconnect the all network together. Okay, for more depth understanding, I am explaining this CIDR and VLSM. Okay, CIDR is classless interdomain routing. This classless interdomain routing, that you are not using the class of IP and you are the host of the another class host. It means you are using the IP of class C. Okay, you are using IP address of class C, but the host, or you can say slash 7, but the 7 is come from where? 7 is come from the class A. Okay, it's come from the class A. Okay, so this, you are the host, you are the part of the network as a host of class A. Okay, borrowing bits from the class A, but you are using the class C. It means it is not class, uh, it is classless. It means classless interdomain routing. It's interdomain, that you are just changing bits from class to class and making their own IP address with the classless one. So this is CIDR. Okay, we will take the example in short, but you just need to understand first then why we are taking this, because some IP address have the more network, some IP address has a less host, so you have to balance it and just borrowing it to just connect with all network or organization or the workstation. That's why it's just like if you are in class C, you are borrowing bits from the class A and you connect the host. It could be possible too. All right, now another thing is VLSM. Of course, I'm giving one example in it. It is basic that you have your global IP on your laptop or your cell phone. If you Google it, where is my IP? What is my IP? Then you are sitting in a like in Baroda, and you are using the device and it's showing some another city like Surat or Ahmedabad, something like that. So it is what? This is variable length subnet. It means your IP is, your global IP is same, but it is what is subnet masking like that. It's masking to protect your global IP. You can check it practically that not the same place you are sitting here, it is showing in your IP in the network. Okay, so this VLSM is used to changing the bits to protect the IP address, and this IP address is public IP address. Okay, so most of the network is to CIDR to connect it the more host. Okay, now let's see the subnetting and their example quickly. Okay, so subnetting is the process to create network by borrowing bits from the host and to create the more network. Okay, if you're using class A, the network is more, but if you're using class C, the host is less. You want to borrow bits from the class A, right? So it is subnetting. If you are not that, you can find the host in between the class C also. So if, okay, I'm taking the example of this example that has set as per the CCN exam or Network Plus exam. Okay, so here is given one office or one organization. Okay, and here is 150. Okay, 150 networks are there. All right, so here is 150 networks, and we need 6 offices are there, but we are planning to opening 10 more office. It means what? It requires 16 hosts. Okay, so what is mean? First of all, uh, understand the question. You have 150 network, you have 10 hosts, but you need more 6 to set up the all network together in the office. Okay, so here I'm writing, just let consider this is 255.255. Then the class is what? The class is B. Okay, you are using class B IP address. Okay, so this 255.255 is network. Okay, and the rest of all is host, is already provided IP address by the network. Okay, by the network, this IP is given. Okay, this part has done, but I need more host, I need more network from this IP only. Okay, so we need more. What we need? 16 subnet. We need 16 subnet with the 150 host. Okay, this is the 150. This all network is connected in the 150, and this 150 is subnetting by the 60 subnet and the 150 host. So this is the one network, or you can say one cloud, and you just borrowing and taking bits and make more sufficient from this network IP or from this class. Okay, so here's the question, that 16 subnet is there and the minimum host is 150. Okay, now 16. Now just remember the binary one, that how we just converted in binary. It's 16 one. Then how much the power of the 16, which is 2 to the power 4. How many bits are required to get 16? It's a 4 bits. Okay, so 4 bits are there, so we need to get 1 on this 4 bit of the host side. Okay, so I put here 1111. Okay, so this one we get what? The 16 subnet. From the subnet we get the binary one, which is 111 and 1. Why? This is 16 subnet that we require. We convert in the what? Binary. Then we get 2 to the power 4. This 4 octet borrow from where? For borrow from the host. Okay, so this is the 111. We get the another network, we get the more network. This 255.255 is a network ID already, but we need to expand, we want to expand. Then we get 4 bits from the host side. Okay, so this is 2 to the power 4, means 16. If you add up this 128 plus 64 plus 32 plus 16, if you add up, you get what? 240. Okay, so what is 240 now? This is class B. 240 is subnet mask. Why subnet mask? Because this network is working on 240 only. So in the range of the 240, the all the workstation are the range that in between the 240, this all is going on. This work is going on only in 240. Okay, I'm talking about the network. Subnet, it means the network ID. Okay, and the host, it means the whatever workstation, whatever PCs are connected in it. So do not get confused in it. Okay, so here asking about the subnet, which I get 111 and 1. So we get the subnet mask of 240. Class B, we get the subnet mask of the 240. And what is rest of it? It is class B. Rest of it is what? If you uh, subtract, total is what? It's a 16. Okay, and you just do subtract of the 4. Okay, you will get 12, right? And this 12 is what? This 12 is your host. You got the question that this is my subnet ID. Okay, it's 244. Find the host. How many hosts are there? So if we require the 16 network, or you can say subnet from the particular IPs, then it's a 16. You convert in the binary, which is 2 to the power 4, which is 16. If the 4 bits are available to get the network, so I just put 1111 in it. If you convert this 1111 in the decimal binary to decimal, then you get the subnet mask, which is 240. Okay, and the rest of all, which is 0000 up to 12 zeros, you can connect with this host. So you get the host is 4095. Okay, and the network you got is subnet, which is 240. Okay, so this is how the IP address we get from the classes. Okay, now how can we arrange? This is the class B address. Subnet is 4094. Okay, and the range of the network is what? 16. So if the IP address start from like um, the last octet would be 140. Okay, so you just add up 16, then you will get the IP address, then you add up 16, then you will get the IP address up to what? Up to 4, up to 240. Whatever 240 network has, the host is 4094. Okay, this is the network one. You finding the sub network ID. Okay, in this next we are finding the subnets, and the rest of all is host. Let's see here. I have the ID, which is 192.168.10.0. Okay, it's 192. It's a class C. That's why we use the subnet mask of 255.255.255. Okay, now here is what we need. A host is 25. Now 25 is not binary number. You cannot divide the 25 in the binary by 2. Okay, so what is nearer one? If you go to the 2 to the power 4 is 16. Okay, but the host is lesser than 25, then you cannot use 2 to the power 4. Now we need 2 to the power 5. What is 2 to the power 5? Is 32. Okay, and 32 is comes under what? 25. You can get the host under the 32. So we just set what? 2 to the power 5. 32 is more but not lesser. More is convenient but not lesser host is convenient. So we take as per the binary that 2 to the power 4 is not convenient. Okay, because it's 16 and we require more than 16 hosts. That's why we took 2 to the power 5, which is 32, and in the 32 we get the 25 host. Okay, so it's 2 to the power 5. How many power? It's 5. How many? It is class C1. What is the class? Is class C, and it is the host is 5. Okay, so we get the host is 5. Okay, 2 to the power 5, which is 32. Okay, but here the question is about the subnet. Okay, you know that here is the host in the class C is only this 8 bits are there. Okay, 8 bits are there. We know the host is 2 to the power 5, which is 32. How many remaining? It's 6, 7, and 8. The rest of all is what is work as a network. So here is 5. Here the question of the subnet, not the host. Okay, so subnetwork you find here is 1 2 to the power 5, and the rest of 6, sorry, rest of 3 is what working as a network. So here is 1 1 1. Why we get the 3 1 here? Because we know the host is 2 to the power 5. As the working the 5, the remaining bits are 6 7 and 8. Okay, so 3 bits are there to use as the network. So I put here 1 1 1. If you add up 128 plus 64 plus 32, you will get 224. What is that? This is the subnet mask. Okay, this is the subnet mask, right? And this 2 to 4 subnet mask is there. The rest of all 3 bits used as a network, and the rest of that 5 bits used as a host. Okay, we're finding here the subnet ID. Rest of all, as we see here, that rest of all is working as a host. So this rest of is 2 to the power 12. So here we use the 4094 host. And this 2, this 4 is used as a network. As well as here, that 2 to the power 5, which is the which is the host that we are getting. Okay, it's 2 to the power 5. It's the host. What is the rest of it in class C? It's 3 bits, 6 7 and 8. So 3 bits can be work as a network. Okay, and that 3 bits work as a network. From the base of that, you add up in the binary 128 64 and 32, you get the 224. It means it is subnet mask is 224. So you get the range of 224, and between this range is IPs are connected, and the class of IP is C. Okay, this the question is based on a CCNA one, basic one. Okay, now let's see this one. Here is given the only subnet mask is 248, nothing else. Okay, it's 248, and the given the subnet mask in 225.225. What does it mean? What does it mean? It is the class B, and it is 248. Subnet mask is occur with the network ID, right? So 248, if you convert 248 in the binary, okay, with respect to 2 to the power 0 to 7, so here is you get 128 plus 64 plus 32 plus 16 plus 8. If you add up this, then you will get the subnet mask is 248. Okay, now you get this one, right? Now what is next? If you do this, then you will get the subnet mask. What does it mean? You do 2 to the power 5, and then you will get 248. This all in even with respect to binary that divisible or multiply by the 2 only. Okay, so it is 248. We get the what? We get the network ID in this area only. Okay, so you get subnet mask 248 and 2 to the power 5. Okay, so 5 ones are there. Okay, now this is the class B. So rest of all is what? It's become a host. Okay, so rest of all is what? Total of class B is what? 16. Okay, so 16, you cut this 5, you got 12. Okay, sorry, you got 11, you cut this 5, then you got 11. So this 11 is become what? Host. So this become 11 is host, then you get the host number. You get the number of hosts from this network. Another question is arised in why I just did -2 here. Then first bit and last bit for the checksum gateway on the acknowledgement. That's why we do -2 all time. Whatever you get the network, whatever you get the host, it has to be minus by the checksum from the acknowledgement. Okay, now the another one is you get the subnet mask is 248. Okay, so we get the 255.255.248.0, and this zero has connected with the host, and this host we get 2046. So these five ones working as a network, and rest of 11 can working as a host. Okay, so this is the with the class I explain it. Okay, next see this is the last one. I know it's over the time, just give me the 2 minutes that I can explain of the CIDR. Okay, now here is 17. What does it meaning 17? 17 is not comes in any class. It's 8. Okay, it's 16, it's 24. Okay, this bits of the network ID, but 17 is not comes in any class. Okay, so this is the classes. If you see the odd number, okay, this slash is called CIDR. If you just see the even number with respect to the binary of 2, you know that this is the in the class. It is in the class IPs that you are using the subnetting. But the slash with odd number which is not even comes in a binary, then it's called the CIDR, which is classless. Now let's see here. We get the subnet mask and the IP2. But here is what? 17. What 17? 16 is there. Okay. Then we want to borrow from the 16. Okay. So 17 is there. So one bit is required for the subnet. So 2 to the power 1. Why I get 2 to the power 1? Because it's 16. And we add up with 1, then we get the 17 one. Okay. So it is 2 to the power 1 is equal to 2. And rest of 16 is what? Is host. Okay. So this is the CIDR, which is the calculated by the subnet mask. So the time is over yet.
Yes, ma'am. Ma'am, time is up, ma'am.
So thank you all of you to listen patiently.
So thank you so much, ma'am, for sharing your valuable knowledge with us.
Okay.
I hope students would have understood the importance of networking as well as the CCNA side of the networking. So is anyone having any doubt, or should we over the session?
No doubt, sir.
Okay, okay. If anyone is having any doubt, they can type in the chat message. I will surely ask that to ma'am. Okay, then if no one is having a doubt, thank you so much, ma'am, for sharing your knowledge. And I'm really grateful that you contributed in this ethical hacking training by sharing the networking side and CCNA side as well as Network Plus side. Thank you so much, ma'am.
Thank you. Have a nice day.
Thank you. Good day, ma'am.